Since its launch into space, the James Webb Telescope has undeniably ushered in a new era. NASA's daily stream of remarkable discoveries from the telescope paints a vivid picture of an uncharted cosmos, teeming with hidden treasures. It feels as though we stand on the brink of an epical revelation, one that could reshape our understanding of reality itself. From casting doubt on the grand Big Bang theory to unveiling breathtaking vistas of distant galaxies, the James Webb Telescope is fundamentally altering our perspective on the universe. The vastness of space, an entity beyond human grasp, becomes palpable. Did you know that, as recently as 2016, estimates pegged the observable universe with approximately 2 trillion galaxies? What enigmas lay concealed within these cosmic conglomerations? Secrets enshrouded in the immeasurable depths of the universe may forever elude us. Yet, technological leaps like the James Webb and Hubble telescopes have broadened our horizons considerably. Given the mind-boggling revelations these iconic instruments have provided, we have come to realize that within the colossal expanse of the universe lies a tapestry of profound mysteries. The sheer breadth of space is strewn with countless conundrums, a veritable labyrinth of perplexities. Recently, scientists achieved a momentous feat. NASA unveiled an image of an enigmatic object, seemingly hailing from a foreign solar system, a sight unlike any other. This marks the second known object to have voyaged beyond our solar confines, and it goes by the name 2I Borisov. In never-before-seen visuals captured by NASA, a remote spiral galaxy stands on the comet's periphery. However, it's the comet's radiant blue core that steals the spotlight, a spectacle tracked by the Hubble Space Telescope as it traverses the cosmos. This image portrays the comet's journey through our solar system, retracing its path to the distant reaches of interstellar space, where it once resided. The tale of 2I Borisov commenced when Gennady Borisov, an amateur astronomer, first spotted a moving celestial body on August 30, 2019, peering through his makeshift telescope. This wandering point of light, now known as 2I Borisov, was confirmed as the first comet and the second extraterrestrial object to venture into our solar neighborhood, free from the gravitational influence of our Sun. Astronomers worldwide mobilized their most potent instruments to glean every possible detail about this enigmatic visitor. Through painstaking observations with the Hubble Space Telescope and the Atacama Large Millimeter Submillimeter Array, ALMA, of the National Radio Astronomy Observatory, astronomers unveiled the comet's extraordinary composition. Remarkably, 2I Borisov possesses an abundance of carbon monoxide surpassing any other comet observed within approximately 300 million kilometers of the Sun. Although the possibility of its formation around a red dwarf, a smaller and fainter star than our Sun, remains speculative, scientists continue to unravel the mysteries of this interstellar voyager. An alternative hypothesis posits that 2I Borisov might be a fragment of a small planet with a significant carbon monoxide composition. Comets, often described as icy, dust-laden, and frozen gas snowballs, typically assume the size of a small town when entirely frozen or dormant. However, when subjected to the Sun's heat, their tails can extend for millions of miles. In the case of 2I Borisov, its length measures approximately 9 football fields or 0.98 kilometers. Nature Astronomy has recently published the latest insights into the comet's composition. All comets originate within the primordial material disk encircling a young star, preserving clues about the distant history of the planetary system. These celestial wanderers divulge the origins of the elements that contributed to the formation of Earth and our neighboring planets, including water. They serve as historical archives. In contrast, an interstellar comet serves as a chemical emissary from an entirely different stellar system, offering valuable information about distant worlds beyond the reach of current space travel. NASA's Hubble Space Telescope captured images of Comet 2I Borisov as it raced through our solar system at a staggering speed of about 177,000 kilometers per hour. While these images revealed a bright nucleus, the nucleus itself remained too diminutive for Hubble to discern. In March 2020, Hubble images disclosed a striking transformation in the comet's appearance. Instead of the previously observed single bright core, the images indicated that a small section had detached from the nucleus. Scientists continued to employ Hubble to monitor the comet closely, The discovery of Borisov spread globally after a week of observations by both amateur and professional astronomers. Researchers managed to track the trajectory of this transient visitor and confirm its extraterrestrial origins. Scientist Bodwitz and colleagues, from December 11, 2019, to January 13, 2020, observed 2I Borisov using Hubble. Separately, on December 15 and 16, 2019, an international team led by Martin Cordina and Stephanie Milham at NASA's Goddard Space Flight Center in Greenbelt, Maryland, used the Atacama Large Millimeter Submillimeter Array, ALMA, a network of radio telescopes in northern Chile at an altitude of 16,570 feet, to study the comet. Radio telescopes are ideal for observing the cold, low-energy gases, such as those found in comets. A high ratio of carbon monoxide to water suggests that the comet may have originated from an icy region comparable to the Kuiper Belt, where Pluto resides in our solar system. According to the Hubble team's theory, a red dwarf, the most common type of star in the Milky Way, could have been the source of 2I Borisov. Planet-forming materials around red dwarfs are colder than those around our Sun due to their smaller size and lower brightness. These conditions are conducive to the creation of comets with the kind of constituents observed in Comet 2I Borisov. Regardless of its stellar origin, scientists using ALMA speculate that 2I Borisov might have initially been part of a dwarf planet with a substantial carbon monoxide layer near its surface. Experts suggest that fragments rich in carbon monoxide could have been released into space through collisions. The ALMA team also notes that 2I Borisov could have naturally evolved into a comet with a significant carbon monoxide content. Alternatively, it could possess an unusually thick outer layer that shields frozen gases like water and hydrogen cyanide. This abundance may appear more pronounced compared to other cometary gases, especially as the more volatile carbon monoxide dissipates or outgasses. Borisov's distinctive characteristics may also hint at a broader spectrum of carbon monoxide compositions within comets, expanding our understanding of our solar system. In any case, 2I Borisov introduces a fresh set of complexities to cometary research. Unlike the Odd Cloud and the Kuiper Belt, which encompasses Pluto, where most comets originate in our solar system, all these comets likely began closer to the Sun. However, the erratic movements of Saturn and Jupiter billions of years ago, driven by the gravitational forces of these massive planets, could have propelled comets further away from the Sun, even redirecting them toward other stars. Given this context, Hubble researchers propose that 2I Borisov may have been deflected in our direction by a giant planet within a red dwarf system, possibly existing in an environment rich in frozen carbon monoxide. Bodwitz speculates that the inward movement of a Jupiter-sized planet could have expelled numerous such comets. The ALMA team concurs, suggesting that the comet was likely set on its course by a young, mobile planet. 2I Borisov embarked on its brief sojourn within our solar system after an extended, frigid odyssey, during which it began emitting gases and unveiling its inner composition. According to findings from both Hubble and ALMA, 2I Borisov contains a more substantial carbon monoxide content than most comets within our solar system. Borisov is rapidly retreating from our Sun and will eventually re-enter interstellar space, never to return. Although the Sun's gravity does exert a slight influence on the comet's trajectory, its path and high velocity prevent it from being captured or pulled into orbit, unlike our Sun and its retinue of planets. Borisov originated in a distinct star system, making it potentially younger or older than our solar system, which is estimated to be around 4.5 billion years old. Most of the time, gravitational interactions with Jupiter have been responsible for liberating comets initially formed in our solar system, allowing them to venture beyond its confines. Therefore, it's reasonable to consider that Borisov underwent a similar expulsion from its original star system. While we haven't directly observed the surface of Borisov, we do know that comets within our own solar system typically exhibit rough surfaces occasionally overlaid with smoother layers of ice and dusty particles. Borisov, being relatively small and lacking sufficient material or mass, cannot sustain its own atmosphere due to the absence of significant gravity. Nonetheless, Borisov has developed a coma, a cloud filled with dust and gas encircling the comet's nucleus. This coma forms as solar energy heats the ice, causing dust to detach from the comet's surface and disperse into space. Professor David Jewett, an expert in astronomy and planetary science at the University of California, Los Angeles, whose team captured the most precise images of this inaugural interstellar comet, clarifies that Hubble offers the most accurate estimate of the nucleus's size, a pivotal aspect of comet Borisov. Their Hubble images have disclosed that the nucleus is notably smaller than previous speculations, measuring less than 500 meters in radius, which is nearly 15 times smaller than initially thought. This size determination is critical as it enables scientists to estimate the overall count and mass of such objects throughout the Milky Way and the solar system. Given that Borisov is the sole observed interstellar comet, they aim to ascertain the existence of others. Only one other extraterrestrial visitor, officially named Oumuamua, was identified in 2017. Oumuamua swiftly departed the solar system, passing the Sun from a distance of 24 million miles. Its rapid speed impeded scientists from obtaining substantial information about it. Initially categorized as a comet, Oumuamua's nature remained uncertain. Subsequent observations following its solar encounter on September 9, 2017, at a blazing velocity of 87.3 kilometers per second, detected no signs of cometary activity. However, more recent measurements indicating slight acceleration have led to its classification as a comet once again. Now that scientists have encountered two enigmatic interstellar entities, they aspire to discover additional such objects and conduct comparative analyses.